Hello everybody, this is going to be a quick demo on how to use values in Racket, sort of compare and contrast it with con cells and pairs. And so let's just dig into it. So first of all, I'm going to build a div mod version where you pass in a numerator and a denominator, it's divisor and dividend. And we're going to build it first as a pair. So let's just write a function. Define div mod pair, and this is just going to be the pair version of this function, where I pass the numerator and denominator, and I'm going to cons. So I'm going to build a con cell out of quotient, which is the sort of div that we're sort of used to. There's actually a divide function in Racket. It returns a rather. I invite you to check it out, or I'll type it in here in a second. Let me just do quotient, and then there's modulo is the other version, or the remainder. That's going to be div mod pair. Just to really quickly, there is a divide function. And if I pass 425 and 231 in, and I run it, I'll actually print this fantastic little number here. We're going to do something where we're going to call this div mod pair of 425 and 231, and it's going to return a con cell for us. Okay, with one, and the one is the quotient, and the remainder is going to be 194. I want you to imagine that I want to use this somewhere, so I'm going to write a quick function that just prints it out. So we're going to do printf of div mod pair addition. And it's going to take a numerator and denominator. And I'm going to declare a local variable. And it's going to be, I'm going to say, we're going to create some locals here. And I'm going to define some pair to be div mod pair. And actually, div mod. And if you want like control \, control / is content assist in Dr. Racket. ND. Then let's define quotient to be the car of the pair, and define the remainder to be the cooter of the pair. And of course, you will not use single letter variables as aggressively as I'm going to do it in this demo. I'm going to call printf. Printf takes a formatted string first. It has this thing where tilde a is going to be the next argument that it gets. So we're going to tilde a over tilde a, and that's going to produce something that is, you know, the quotient. I'll just write that out, tilde a with remainder tilde a. Okay, and I'll put a new line at the end just because I know it's going to be nice when that prints out. And now the ND and the quotient and the remainder. Very reasonable function. And now if I call printf div mod and hit my control / it doesn't have anything for that. So that's kind of div mod pair. So maybe I didn't define that correctly. I don't know why I didn't come up with that, but either way, we'll just copy it in here. 425, 231, and see if I made a mistake. If I run this, oh yeah, div mod, and it should be div mod pair, and run that, and now we're good. Okay, so that's the pair version, and I want to build it as values next. So first of all, you just swipe these two, right? And I'm going to call make div mod, and we're going to make the values version. The only difference is going to be that I'm going to change this to values. And values can be, it's sort of like creating a tuple. It doesn't have to be just two things. If you were building like a date, you could make, you know, year, month, day, or whatever you want. You can make, this sort of takes a variable length list. You can sort of, as I showed in one of the other videos, you can sort of explore it. You can look at the documentation there. But now on the other side, I'm going to say like, well, let's make one that does, that prints out this way also. I'm going to call div mod pair, and instead of getting a con cell back or pair, I'm just going to be able to say like define values, and I'm going to just put quotient and remainder in here. And now I don't have to like pull it out or anything. So now when I run this version, now when I run that, this is the same value. Just kind of like this, it's nice in ML where you could like pattern match and pull out a tuple into some values. ML is certainly not the only language that does that, like Python and Ruby. Everybody lets you sort of extract these values. So it's kind of nice to be able to do it in that style. Like I showed off before, there is a divide function. There's also, of course, a function that does this div mod version. And nicely, I think it's quotient remainder. And if I run that, that also works. So it's kind of a nice bit of, this is not the esoteric feature that no one uses. When they built quotient remainder for Racket, they built it with values as well. So hopefully that'll help. When I was building, when I built the streams framework, I chose to use values over a pair or a console simply because it seemed like a very reasonable thing when you were saying, all right, here's a stream, give me the next value in the next stream. I could have built it as two separate functions, but they sort of repeat a lot of the same code. It's kind of nice once you've got them to just return them both. I could have done it as a console, but it felt better to be able to just sort of extract both of those things with this define values. There's also let values, let star values. There's sort of every incantation that you want. So hopefully this will help you use it in the Thumpkin Streams framework, but also show you how to build it, but also how to use it.